Thank you very much for inviting me to speak today. Um, I like talking on irrigation. My kids always think I'm kind of weird for that, but I really do like talking about irrigation. I've worked in it for the last 30 years within RCS. So I'm just going to cover some of the things that I've kind of learned on furrow irrigation over these last 30 years. Usually when I bring up furrow irrigation, it has a bad reputation as far as most people think it's something that they really want to get away from, and it's just kind of an old hangover that's out there, which it can be done very poorly, and I can understand that, but there is ways that we can make furrow irrigation much more efficient. And so what I just want to cover today is how you can do that and some of the experiences I've seen with that as far as how to do it. The big thing I have seen with furrow irrigation is really it's a step-by-step process when you work with furrow irrigation that you have to follow things in order. And if you really do these 5 steps, and I know irrigation scheduling really doesn't apply to efficiency, but I think it's still a necessary part of doing a good furrow irrigation plan. But if you can do these all in order, you can have a very efficient system out there. The problem I usually see are people read articles saying the Delta Farm Press, or they may hear some podcast and it may talk about something with scheduling or something with surge irrigation, or something along that line. A lot of times farmers want to jump in and do that particular thing, but they get out of order when they do that. So if they don't have the first steps really completed, then a lot of times they don't get the maximum benefit of the whatever they've read about and are trying to incorporate in their system. So I just want to talk about each of the different parts and how I've seen that affect a furrow irrigation system. Please feel free if anybody's got questions as I talk about different parts. I can expand on that or try to, and I'm very open to discussion, or if people have different opinions on things I'm going to talk about. Okay, so let's start off with the first part, and that's really drainage. This was something that since I was a kid has always been really beat into me, that drainage is one of the most important things you can do with an irrigation system, a furrow irrigation system, that you have to have that set. Again, this is what I'm going to be talking about is really for the Mid-South and for the Delta region. In different parts of the country that may be a little bit different, but where we have so much rainfall and everything else involved, that drainage is key before anything else. Drainage is more important than irrigation, really, and that we've got to get our system set up so that we do not have flats or reverses out in fields, and getting that all together. You can do whole schemes, you can do surge irrigation, do scheduling, but if you don't have your drainage right, you're really not getting the maximum benefit that you can get. Now, back in the early 2000s, I started working with quite a few systems where we were doing tile drainage and sub-irrigation. And when we would design systems, the program we would work with most would be DrainMod. And I really liked that program because it did a good job of trying to quantify some of the effects that you had from waterlogging on systems. So I've kind of interpreted that a little bit over for furrow irrigation as well. And one of the things that it looked at was called the Stress Day Index. And this was from the DrainMod program. And in that DrainMod program, it looked at factors such as what is the percent of the upper foot of the soil and excessive field capacity, what plant growth stage, and what crop. And although I don't know that it's exactly right as far as the percentage and yield loss that you can expect from it, I feel very confident it's directionally correct because it validates a lot of what I've seen in the field. So based on that program, when I've looked at fields that have issues with drainage, just one day of excess water for any part of the field that suffers that, it's going to see an early vegetative, it's going to get a 3% reduction, at tasseling 5%, ear development 2%. So that's for every 1 day period where you have that excess water out there. So say if you do 6, 7 irrigations in a season, if you have parts of the field that you're causing to drown out, that part will suffer that much yield loss, or directionally, that's how much is anticipated. If you break it down to 2 days of excess water, this is kind of what the program anticipated with the Stress Day Index. Again, up to 12% reduction for that particular section for every 2 consecutive days of excess water in a field. Now, I show this picture here, and it's probably a little bit unfair. This is actually a tiled field, but I know it applies to furrow irrigation as well. As you can see, you've got a flat area out here with the reverse in it that's actually ponding water. And so you definitely, as you see parts of fields like that, you will experience yield loss if you have that in sections of the field. So again, I can't emphasize enough how important it is to have a good drainage system on any field that you're working with on furrow irrigation in the Mid-South. Okay, once you get your drainage size set up, really the next step is getting a set size. This is something I try to work with every farmer that I deal with down here in the Boot Heel of Missouri. You're really stressed on getting the adequate set sizes for the soil textures they have on the field. Back in the 90s, when we used to do a lot of furrow flume studies where we would look at the soil textures and use programs like Windsurfer, or even when Surface came along a little later, we would try to get matched furrow flows to the soil texture we had in the field. It was a little tricky with some of that because different farmers have different setups on how they set up the rows and everything, but we did get a pretty good guidance on our soil textures for here in Missouri, at least, as far as recommended flows. And what we looked at was really a standard size is a 1/4 mile row, and most of our slopes are going to be in that 10th to 10th and a half slope. So that's what we set up a lot of our systems with. And then we were always trying to make sure that we could get an irrigation in about a 12 to 18 hour time. If you're less than that, a lot of times you're not getting a very good soak. And once you start going over 18 hours, you're starting getting to issues of excess water and waterlogging on the upper part of your field. So that's always been kind of a target when we come up with set sizes. So, you know, if you haven't run the Windsurfer program, and like I said, those get quite a bit of data hungry on those, we kind of use these rules of thumb for our furrow flows. So if you've got more of a sandy, fine textured soil, we've always tried to get up around 20 gallons per minute per watered furrow. And sometimes in excess of that, if we can. That would also be like on a cracking soil. A lot of times we have a sharky soil in our area. It cracks quite a bit. And so those require higher flows trying to get the water to advance down into the flows. On the other end of it, if we've got more rice soils, the silty clay loams, we really do not need near that much water, and we can get away with 7 to 10 gallons per minute. So what that looks like, you know, if we just take a scenario with a Calhoun, which is a good rice soil in our area, if you're doing 30-inch rows, so we water it typically in our area, we do every other row. So that's going to be a 60-inch watered furrow spacing, 264 watered furrows on a quarter. If you had a 2,500 gallon minute well, you could do that field in one set because that would average you about 9.5 gallons a minute. You know, if you look at a scenario 2, if we had a Fahrenberg soil, that's a fine sandy loam, that's where we're looking at, we need 20 gallons a minute. So a lot of times I try to work with farmers to say, this is how many sets it looks like you need on the field. And a lot of times when you work with them and when they farmed the field for several years, they know that as well. And so we try to get their fields organized and set up so that they're not trying to water too many acres at the same time. And it can be challenging because obviously farmers are farming lots more ground than what they used to. And so the more sets they have to handle, and that's the more time they have to get to these fields, a lot more work. But in the end, if you want an efficient system, you've really got to match soil textures and soil flows to get that set up correctly. Okay. So once you get those two set up, that's really where we get into the pipe distribution uniformity. That's where we're getting into using hole sizing with the poly pipe. That a lot of times people want to jump to this step before they get the step 1 and 2 done correctly. And again, that's where you're not going to have the efficiencies with it. The key is what we're trying to do. And I don't know if you can see my cursor or not, but what we're trying to do is get to the, if all the rows are the same length and we have the same soil texture in the field, then we want the same amount of flow coming out of the holes by the pump versus the very end of the poly pipe as well. So back in the 90s, I used to work in what's called an irrigation and water quality office that we had here in Missouri for NRCS. And our whole goal was just to work with irrigators and trying to improve their systems. And so one of the things that we came up with was the faucet program. And this faucet program, the idea behind it was just a computer program to calculate what hole sizes would give an equal flow for each furrow, or it would balance the flows if you had different row lengths to give you the best pipe distribution uniformity with it. It was a great program. We're really blessed to have a Doyle Birch as a programmer, and he was able to put this together for us. I still use the faucet program. I'm so used to it. I mean, I know the program really in and out, so I can go through it pretty quick. But if any of you all have ever dealt with computer programs over the years, you have to update them to new platforms. You know, if you look on this, it talks about using Windows NT, 2000, XP, and Vista. You know, as we keep expanding out into Windows 11 and further, at some point, faucet's just not going to run. We are very fortunate to have Delta Plastics. They contacted us several years in the past, and we talked to them about, you know, how we program faucet, and they use that kind of their nuts and bolts, and they have developed an excellent program, Delta Plastics Pipe Planner. And I use faucet myself, but when we train people, we train them on the Delta Plastics program, and it does an excellent job with that pipe distribution uniformity on systems. Now, the big thing we always try to consider with people is to make sure they understand that is just telling us the evenness of the water coming out of the pipe. It doesn't necessarily, in some cases, match up with the flow getting down to, or the evenness of the flow getting down the furrows. So, you know, if you get a field like what I'm showing here with multiple textures in the field, maybe you got sand blows, things like that. Maybe you have some different row slopes in the field as well. The program does not account for that, either pipe planner or faucet. So you can have some issues with that you have to consider over time. But one of the things that I like doing with this is, you know, how much of a difference does this program actually make as far as on a field? You know, is it really worthwhile? Is that much of a difference on getting your evenness of flow coming out of that pipe? So I use this example, and it's getting a little dated on me, but this is from a cotton field back in 2010. It's probably 5-6 miles from my office here that I've worked with this farmer quite a bit. So if you look at the yields, they're a little bit lower than what we would expect today, but I still think it gets the main point across with it. So this is from his yield map. So the system's set up like this. There's a well here in the center. This is 87 acres, something like that, the overall field size. So he has a pipe running to the west, pipe running to the east. I think this is around 2,500 gallons a minute. So what the farmer was doing back in 2010 was he would punch the same hole size for his entire system. So the same holes up here is the same holes down here on his poly pipe. So what ended up happening is that obviously you're going to have higher pressure up here by your well versus down here. So if you have the same hole size, you're putting out more water up here by the well. So if you look at this field and you see the shape, and I've kind of drawn this in here, what you're going to see is more of this brown or the lower yield versus the green is what we're really wanting to get to on his field. This is a result of oversaturation on his field. This is all one soil texture on his field. So it's not because we have different soil textures out there. Now this, to me, appears to be strictly from overwatering on his field. So if you look at this, and I'm just going to use a number of 88 cents a pound for cotton. I don't know if that's good or not currently, but it should be close. As harvested, that would be about $80,350. This yellow, the center, again, that's right there on this average, $80,750. Just by doing a few different hole sizes, nothing else, trying to even out the flow on this field. And if we could get him up to this green section right here, that's $96,050. Getting to the dark green, $1,004. So basically, by just changing his holes on his field, he cost him by just having one hole size and not changing holes on this field for this year, it cost him anywhere between $16,000 and $24,000 just on 87 acres. So it was a significant difference just by going to a whole scheme on his field. So I always try to show this to show that it can make a difference on a field just by doing something simple. As management using a pipe planner or a faucet program on that. Okay, so really once you get steps 1, 2, and 3 done on a furrow irrigation field, you're really in pretty good shape. It's kind of like it's the cake of the system. So it's just the foundation. You've got a nice cake if you've got steps 1, 2, and 3. But we usually try to get the icing on the cake, and that's really surge irrigation and scheduling as well when we work with irrigators. We've been working heavily with surge since the 90s in our area, and we found it to be very effective at getting a more efficient irrigation out there. Obviously, through advance, The advanced part of the system, we've seen that it's got the water through quicker than if we're just doing a continuous irrigation. But really where we get our water savings is in the soak cycle. So again, I know probably a lot of you all have seen surge irrigation and how it works. But basically, if you haven't, the way surge works, it's a butterfly valve, usually located at the pump. And then it's going to start watering on one side, and then you're going to have it programmed so it waters on the other side, allowing the one side you originally started with to dry out a little bit. It's going to keep going through these advances through the field, back and forth until it gets to the end. Okay, so in this advanced stage, like I said, we've seen some fields that maybe have been hard to water that you're able to get water through with surge irrigation that maybe you haven't. But where your real savings, what we've come up with, or what we've seen, at least with surge valves, are that's called the advanced cycle. So once it finishes advancing water to the end of the field, a surge valve will go into the advanced cycle where it just waters the complete length of the field, and then it changes back over to the other side of the field, if you've got it programmed correctly. When it does this, it continues to do this till you actually shut off your surge valve. And most farmers, again, are farming many more acres, especially since now the poly pipe's around and farmers are now not hampered by having to use gated pipe, storage, labor, everything involved with that. So we farm many, many, many more acres than what they ever have before. And so they don't babysit a lot of their irrigated fields nearly as closely as what they used to could. And so, they may be out spraying, and so they're not going to get to the irrigation pumps in a timely manner. If it's in an advanced cycle, it just continues to do that, keeping the water on the field. In many cases, that keeps, even though it's going deeper down the root zone, it's still usable on that particular crop. So we find that will save us quite a bit of water rather than just running the water off into our drainage ditches. It can keep it on the field. So surge irrigation is a definite plus on farms. Again, farmers really like it too, because I'm trying to convince them in step 2 that they probably need more sets, in some cases at least, depending on their soil texture. So if they do a surge valve now, they're operating 2 different sets at the same time, and so it does save on labor as well. But again, that's more the icing on the cake. If you can get farmers to move to that, that's what we definitely try to do. Now, once we get to that, then what we're really looking at is scheduling. And I know that's not exactly the efficiency of it, but is something I really think is important with our furrow irrigation systems. If you'd asked me this back in the 90s, I would have probably been just the opposite on this. We used to work with a lot of different moisture sensors. We had a weather network that we would work with, and they were all good. But for field scale farming where you're doing multiple acres, they took a lot of work to keep up with. And so what I saw is most farmers, it just wasn't practical for them. But as the telemetry improved and a lot of our computer platforms improved, I really did a 180 on this. And usually as we got in the 2000s, 2010s like that, I really started pushing farmers, encouraging them to use soil moisture sensors and the weather networks that are available. We're really fortunate in Missouri that we have a very good weather network through Extension that is free for our farmers. Dr. Gene Stevens did an excellent job making this farmer friendly, where we'd use NOAA to get our precipitation that would automatically go into the program, and then our weather networks to actually come up with our ET values. When it first came out, I was skeptical, and then I started using it on several fields, and I was just shocked how accurate it really was. So I was very happy with it. Same with the soil moisture sensors. With, again, the telemetry improving, there was a lot of good things coming out of those. But what I really came up with from using both of those is that for me to get a really good irrigation schedule, I really need to use both soil moisture sensors and a weather network together to really get a good recommendation on when I need to do it. And kind of to show you, I mean, and I know there's lots of different platforms out there. Some of them use fuel gauges. There's different things along that line. But again, this used to be the way that most farmers would see our irrigation soil moisture sensors. They'd see a lot of graphs like this, and they get overwhelmed quite a bit. Again, so I know there's the fuel gauges and other things out there with a lot of these systems. But what I tend to find with those is that they start irrigations a little sooner than what they have to, because it's very hard to estimate what the water content of that soil is. And so most of these systems are going to end up triggering, like I said, a little bit earlier. The way I usually prefer to do it when I'm using the soil moisture sensors is really just looking at the slopes of the line. So once the slopes start flattening out, then I know that the plant's stressing more trying to get that water. And as I see that flattening, then I know that's when to trigger an irrigation for a system. The problem you get into, at least in our area and in the Mid-South, is our variability of weather, that we might have cloudy days or more windy days that change that ET enough that that slope may be because of the change in ET, and it may not be as much as a reflection of the plant stressing to get the water. So sometimes that will mess me up a little bit as far as telling when to trigger an irrigation. So that's where I really like having the weather network in place as well. So I can take a look at it, and it can kind of tell me what if the ET actually changed over that day. Is that why the drop in the soil moisture sensor is that coming up? The problem with the weather networks is because that's trying to figure out when you need to irrigate, but it's going to need to know what is actually a good root zone on a plant. And again, in my area, I can have root zones all over the place where they heavily till. A lot of times we get into plow pans. We can have some restrictive layers in there, so we can't get a very deep root zone. I've seen many times on soil moisture sensors that after we've irrigated, we've only penetrated water 8 to 12 inches in the soil. On other fields where they're using soil health or they've got much less tillage, and we're able to get water down 24 inches off furrow irrigation. So it can vary quite a bit. And how that affects the schedule, at least what I've seen is that here was an example from 2017 I did on a layer silt loam. If I'm planning with the weather network and scheduling through it, if I plan with an 8-inch root zone, what it called for this summer, if corn planted on April 5th, was 9 irrigations. So the red is the dates of the irrigations that would have been needed if I would have planned that with an 8-inch root zone. If I would have doubled that root zone, I could have dropped it to just 4 irrigations over that summer based on it. If I can get up to 24 inches of a root zone, I could have been down to 3 irrigations would have been called for in that summer. So there's quite a bit of variation on that. And it can make a significant difference. So that's where having the soil moisture sensors, really seeing how far you're penetrating water and also seeing where those root zones are, that's where that really comes into play to be able to balance that out. So what I tend to try to look at is a combination of both. I will try to look at the graphs, see when it's showing the irrigation called for, and see if there is a change. Is that because when I look at the weather station that the ET has changed, that's causing the change in slope? Or is it because the soil, the plant's having more energy trying to pull that water out of the soil? Ideally, I mean, I can do this visually, although it takes a little time to do it. I like graphs. I like looking at tables. I'm not a farmer. Most farmers didn't get into farming to be doing things like that. So they're not going to probably make the effort that I'm making as far as looking at that. And ideally, I think this would be a great research project, or for some company to come up with it, is a way to actually correspond the drops that you look on the soil moisture sensors and compare that to ET. And then if you started seeing that the ET was different than what the drop was showing on the soil moisture sensor, that would trigger your irrigation, knowing that your crop is stressing a little bit more, trying to pull that water out. And that to me would be the ultimate scheduler. So farmers would not have to worry about trigger points, trying to figure out what the water holding capacity of that soil was. It could be automatically taken care of. And I don't think it would be that difficult to get those correlated, but like anything, it takes time and it would take some effort to do that. And again, you got different brands of soil moisture sensors trying to correlate all those. So I know it could get a little complicated there. But I think it would make a drastic difference on farms. That it would definitely change how people schedule and what they look at. So really, that's just kind of me going through things very quickly and in a nutshell as far as what I look at with furrow irrigation and trying to get an efficient system. I truly believe that we can get efficient furrow irrigation systems, and that it shouldn't be something that's just kind of thrown to the wayside. It just takes a little time and effort, and just really following through that design process in order. And if you do that, you can have an efficient furrow irrigation system. So that picture right there, that's Keith Admire and Doyle Birch. They're the ones who I worked with back in the 90s in the irrigation office. They were geniuses when it came to irrigation and everything involved with it. And I just learned a lot with them. So I always like to give them credit for all the great work that they did. But that's really what I have in a nutshell. If people have questions or comments or anything you'd like to bring up, I'd be glad to answer questions or again, take comments, whatever anybody had.
Thanks, John. Any questions in the room or online? If you have any online, just go ahead and type them in or chime in. But first I'll go to the room.
No question, is this an hour long and then we'll do an hour later, or is this a 30-minute? I didn't know what the time frame.
It was a 30-minute plus questions.
Oh, okay.
And then brief switch over.
Okay, got it.
Hello, Dr. Esther, how you doing?
Yes, I'm doing good, doing real good.
Thank you for this presentation. And I have a question. So I'm a student here at the National Center for Alluvial Aquifer Research, and I was wondering about, when I start reading about the different computer hole selection, one of the first stuff that I found in the literature is faucet. But then when you go to the talk to the extension meeting, they are more familiar with Delta plastic.
Yes.
And, but how would that work? Because faucet was designed from NRCS, and then how that work? Do you sell the patent, or they just share the information how to run the program? Because
so when Pipe Planner started, Phil Tacker used to work with Arkansas Extension, and then Phil went and retired and went to work with Delta Plastics. So Phil Tacker had contacted me up here in Missouri, and he asked if I would go through the program myself and Doyle Birch. He was still up here. And so what we did is we just went through, this is the logic behind it. To calculate the hole sizes, that's an iterative process as far as how you do that. And so we went through as far as this is how the program worked, this is how it determines hole sizes, and really went through the whole process with them. And then based on that, Phil and the programmers kind of got together, and that's what they used to come up with the Delta Plastics program. So it's using the same logic in there. It's just Delta Plastics did an excellent job of adding things to make it much more user-friendly for farmers. Faucet was great for me, and again, the way I like to do things, but honestly, for farmers, it could be a lot more complicated. So it's just a different target audience really between the two programs, but they should essentially give you the same answer regardless of which program you use.
now we know. Thank you.
Yes.
Any other questions? Yeah.
Oh, two different questions, I guess. Again, Dr. Hester, thank you for your presentation. We are working on that scheduler or scheduling method you were talking about with the slopes of the soil moisture decline, and I'm assuming that's probably coming from maybe a Syntec drill and drop or something of that nature.
That's perfect. That is a Syntec drill and drop.
Yeah, if you would like to try that on your boot heel soils, we can get in touch. And
so again, what my issue is, and hopefully, and maybe this is what you've done, if you can see my cursor, I don't know if you can, but where I've got that on the data.
Very well, very clearly.
So you can see this drop right here versus this drop. There's a significant difference between here and here. That is strictly an ET difference on those days. So what would end up happening is I'm going to get a much steeper drop here because I had much more ET. And then, versus over here, it's a little bit less. It's still, the plant's not stressing getting water. It's just an ET difference. Yes. And so if you've got that correlated to a weather network, man, that would be awesome, because I find so many farmers water so much earlier than what they need to.
Yeah, we're normalizing the decline in the sensor with calculated crop ET. So
oh man, I would love to see
it's just an Excel spreadsheet right now. I don't want to get your hopes up, but if we could communicate further if that's something that you're actively involved with in Missouri? Because,
I am
here,
interested in
we're
it.
much more on the, silt loam to heavy clay soil range, and you have a lot more of the finer texture soil, coarser texture soils up in the boot heel, so.
Well, we have everything, and I think that's a lot of areas because we have a lot of our earthquake soils where we've got the
Yeah.
sand intrusions in there, but we have a lot of heavy soils as well. So if we could get a correlation, I mean, again, it just makes it simpler for farmers because, again, they're not having to sit through and try and interpret all this. It could do that almost directly for them. That would be great.
Sure, and another question, here on station, at least, we have plots that are, very short in furrow length. And, the soil type is such that the infiltration rates are low. I'm sure that some of that also happens, but to a lesser extent because of longer furrow runs on, farmers' fields, where we just don't have very much infiltration. Yeah, what in your experience has worked? I mean, I could see using surge irrigation a little bit, we could probably cut down on the tailwater side of things, but, that, on a time basis, it would probably have less infiltration overall, but we're just able to, probably generate less tailwater.
But the issue, yeah, if you're getting into the advanced cycle and you have it programmed up right, you're just gonna have to run it longer trying to get the soak in. So there's a couple things we've kind of looked at up here. One is we tend to do every other furrow irrigation, but that may be if you're having difficulty getting it soaked in, that may be where you're going to every furrow. Because again, it's not an issue of a high flow that you need to get through there. It's just getting it to have a bigger soak. So that may be going to an every row irrigation. But the other thing, and this is something I gotta admit, I tend to start skeptical. Missouri's a show me state, and I tend to really live that, and that you got to prove it to me. And so a lot of the farmers up here went to the soil health where they're doing minimal to no tillage, and they're definitely doing the cover crops in there. They have definitely expanded their root zone. And so we're getting, so what I've looked at the soil moisture sensors that on those fields, they are getting that water penetrating down to that 24-inch range or more. So it ends up you have to do smaller sets in order to get that water. So you're not having it out there too long and waterlogging, but you can fill up a much bigger storage area. And once you can get up to that 24 inches or more, I mean, you're going to need less irrigations. And anytime you're furrow irrigation, especially, every irrigation helps the crop, but it hurts the crop initially. There's always that shock factor just a little bit on a crop. So I am convinced that larger irrigations are better and less of them than if you have to do a lot of smaller irrigations. And where I see a lot of the smaller irrigations where we're not getting infiltration deeper in the ground. So I have become more of a believer in doing the soil health and doing more of the some cover crops, something to open up that soil. Now you could look at deep ripping as well on a field and trying to open that up, trying to get rid of some of those plow pans, but definitely less tillage as much as possible, trying to open up the soils. It makes a difference to give you a much bigger ability to soak that water down. That's what I've seen up here.
Okay, thank you.